The day is here. Today is the day we discuss derivatives. So, a derivative is the answer to the question, how can you find the slope of a non-linear function? Well, the instinct is to, if we wanted to find the slope, say here, we would say, okay, let's draw this line and see if we can get this line to be as close as possible. But it's hard to tell exactly what that slope is, and we're trying to figure out what that slope is. So the idea that we're going to try to do is take 2 points that almost make a line and connect them and find the slope from that. So slope, again, is y2 minus y1 over x2 minus x1. If we put this in function notation, it's f of x2 minus f of x1 over x2 minus x1. So if we have the slope between a and a plus h, let's say here is the point whose x-coordinate is a, and then we add some h value to it, that would give us a plus h is there. It's given by the slope formula. So we'd take a plus h, and the output there, this is a plus h, comma, f of a plus h, and this is a, comma, f of a. We'd find the slope between that. F of a over a plus h minus a. Well, we can simplify this. F of a plus h minus f of a over, subtract those, and we're left with h. And this is what we call a difference quotient. Now, this is not exactly the slope. This is the slope of the blue line, which is not equal to the slope of the red line, or the red curve, which is not a line. So how do we take this idea of a difference quotient? Well, and turn it into a slope. Well, the idea here is if we have this idea of a difference quotient, I have this here, and I can change what h is. And the further away h is, the further away I get from the slope. And the smaller h's, the closer together those 2 points are, the closer and closer I get to the slope. So the idea is, if we make h smaller and smaller, the distance between those 2 points smaller and smaller, then they get closer and closer together. And this is why we have limits, because if we actually have them on top of each other, well, we'd be doing change in y is 0 divided by change in x is 0. So if we found the slope between a point and itself, it'd be 0 over 0, which is indeterminate form. But if we change h, if we take h and make it smaller and smaller, the limit as h approaches 0 of the difference quotient should give us the slope. And the closer these 2 points get, the closer we will get to the slope. So, define the derivative of f of x at a point is defined as f prime of x equals the limit as h goes to 0 of the difference quotient, f of x plus h minus f of x over h. This is the first incredibly important thing to know in calculus. This is the definition of a derivative. The derivative is the function that outputs the slope of f of x at the point x comma f of x. So what that means is, if I want to know the slope of some equation, if I find the derivative of that graph, I can use this derivative and say that, okay, f prime of 3 means the slope of f of x at 3, or when x equals 3. This is a derivative, and we will be using this definition to calculate what derivatives are, and then we will be using derivatives to solve all the types of problems we could do with linear equations that we couldn't do with more complicated equations because we didn't know their slopes. So, again, recap. The derivative is the difference quotient as h approaches 0, because these get closer and closer to 0, meaning that the slope gets closer and closer to the actual slope. And we can use this to solve all sorts of problems that we care about having the slope of a function with. Thanks.